cobbler, as usually we're going to use that the econometric, okay, econometric analysis in the production theory. Okay, econometric is something like blended with everything. Okay, economy, microeconomy, macroeconomy, okay, statistic, everything will be in that we call econometric. Okay, the topics is huge. Okay, it's a huge topics, but I just only pick that the particular part which is we're going to adopt in the production theory. Okay, there we can find that the Cobb-Douglas theorem. Okay, now take a look at the Cobb-Douglas production function. Okay, these are generally the Cobb-Douglas production function. These are full form, guys. Don't get confused. All right, this is a general function. So certain function that is we use in the models, but we're not going to use here. I just give you that full forms. How does it look like? Okay, so later you don't get confused this. So as long as when you look at the formula, you know, right, this is a Douglas Cobb-Douglas theorem or Douglas function. Okay, so as well the Q stand for the output, the A stand for that the measurements. So we can say that how much the output we would get, okay, for the 1 unit of each input. The L stand for the labor, as I said earlier. K is the capital, and then the E is just natural logarithms. With that, U is a stochastic disturbance terms. Okay, is a stochastic function. All right, not in your syllabus. This function is purposely they include in that Douglas equation because the disturbance, the stochastic disturbance is one of the elements. They make changes in that the production function or production theorem in the econometry. Okay, so some for your level you're not gonna use anyway, so don't worry about that. Okay. Okay. So the beta 1 and beta 2 is a very important. This is what we're going to analyze this. Beta 1, beta 2 is that the two parameters is a very important. It will show that how much the amount of the output respond to the changes in the input. So this is very important. Beta 1 and beta 2. Okay. Now take a look this the problem. Okay. Yeah. So usually the Cobb-Douglas function will be like this. Okay, the second one. Okay, the first one is general form with that stochastic disturbance. The second one is a usually in a very very basic things. Okay, you can learn it anyway. For your level. Okay, it will be in that form. Okay. All right. So as we know that the function, this function, the Cobb-Douglas for a function, we call as a log function or double log function, or also they call as log linear model. Okay, or log linear function. Okay, because why they call as a log linear function? Because the function is come up with the natural logarithm. As well, the function is basically is a linear function. That's why they call log linear function. Okay, so don't get confused. Log is actually is a non-linear, but in the sense of this, so logarithm function, we trying to linearizing the function from that non-linear cases. So this function we call a log linear function. That means is a linear statement. So A is the stand for that the beta naught is a coefficient value. Okay, we call as a constant. Okay, so we can express this is in the form of a regression model. Have you heard a regression function before? Regression model in statistics? Probably in the first semester. Does anyone these terms?
Yes, I've heard it.
Yes, very good, very good. Okay, so beta naught is a constant, as you know, and then beta 1 is a parameter. Okay, beta 2 as well as a parameter. Okay, so based on that, we be able to discuss that the things. All right, these the models. Okay, the estimated coefficient of the parameters, the coefficient parameters is a beta 1 is actually is the elasticity of the output with the respect to the labor input. Okay, which is measure the percentage change in the output for the 1% change in the labor input, and it holds that the capital input constants. Okay, that's the definition for the beta 1. Okay, likewise in the beta 2, it's the same thing. Elasticity of the output, okay, with the respect to the capital input holding the labor input constants. Okay, so the beta 1 is holding based on the capital, the beta 2 is the whole based on the labor. Okay, that's a difference. Okay, so yeah, so we can see that the some of the model, how we can interpret the models based on this. All right, this is we call a sum. All right, the beta 1 and beta 2. Okay, we call like if it is the beta 1 or beta 2, say the value is 1. Okay, say the 1. The constants return to the scale. That means the doubling that input will double the output, and tripling that input will be triple the output. Okay, so the mean is a like a increasing, is a proportional. Okay, say if it is that the beta 1 and beta 2 is a less than 1. Okay, say is a decreasing return to scale. Okay, so we call a decreasing to the scale, which mean if it is doubling the input, it will be it will be the less than double that output. Okay, so you know the trend. Okay, is a doubling the input, then it will be less than doubling that input output. Say if it is the 1 is a greater than 1, say the beta 1 and beta 2 is greater than 1. So there is an increasing return to the scale. They call the terms they call increasing return to scale, which means doubling the input will be more than doubling the output. Okay, so these are three category where the coefficient parameters for the beta 1, beta 2, the value is changes. Okay, the three cases are when it is 1, when it is less than 1, when it is greater than 1. So that is the terms we use. Okay, so try to understand. I mean, yeah, you should understand. In order to try to understand, you should understand. Okay, the three things. Okay, the trend how will be look like the output and the input. Okay, if input increase, what happened to the output when the beta 1 and beta 2 is 1. Likewise, when if it is a beta 1, beta 2 is a less than 1, and what will be if beta 1, beta 2 will be greater than 1. So you need to know the three phenomenon of that, the production for the input as well in the output. Okay. Say now, take this example. This one of the real application. This is a real application. Now look like the real application will be. Okay. This is one of that model taken from that agriculture sector in Taiwan between 1958 to 1972. Okay, so the log linear model is given as is in the slide. Okay, that's the log linear model. Now we use that the regression model we generate based on that the ordinary least square method. Okay, or OLS. Okay, ordinary least square method. And we obtain this model as stated in that slide. So we can see that the 1.499 for the beta 1 and the beta 2 is 0.490. Okay, now we can see that trend. How does it works? Okay, the output of elasticity of labor and the output elasticity of the capital. So when we add these two, okay, we can see the total is a 1.989. Okay, that means we know that is increasing. Okay, they will be show that increasing return to the scale. Okay, based on the things, the one we just done right is now, right? So when we add these two, so we get is the total is that more than 1, which is 1.9 something. So that means we can claim that the return will be increasing. Okay,